Good day, I'm ADRIAN TINIO.
Good day. I'm NICOLE M. Santa Ana.
First of all, good day to all. We are here to present our thesis paper entitled Gender Classification for a Day-Old Gallus Domesticus using Image Processing. I am Mark J. BERBOSO, together with my fellow researchers KEAN Nicole Santa Ana and ADRIAN TINIO, with our advisors Engineer Joseph Bryan G. Ibarra and Mary Ann Latina. In this slide, it talks all about the background of the study. In poultry business, pullets have the important role on breeding their kind, which they are the ones who lay eggs. Pullets are the egg producers and grow faster than the cockerels, which make the cockerels less desirable than the pullets. Here are the statement of the problem. Based on the statement of Rovilo Vaccination Services, newly trained chick sexers' average percent error is about roughly 15%, and the number of chick sexers is decreasing briskly around the world. Different countries are suffering now for lack of chick sexers. So our main objective is to produce a device that can accurately identify the gender of a broiler and layer chicks after a day as it hatched. Then our specific objectives are as follows. 1. To develop a system that can classify the gender of broiler and layer chicks using SIF algorithm. 2. To compare the results of the system with the expert, newly trained sexer, and the actual gender of the chick. And lastly, to verify the functionality and accuracy of the system through confusion matrix, and if there is a significant difference between the system's reading and the actual gender of the chick using statistical analysis. So the scope and the limitations are as follows. This study is only for feather sexing newly hatched broiler and layer chicks. The device will only identify the pattern present in a chick's wingtips and classify it as a male or a female. Here is the portable device of our system. LED was used for outputting the gender of the chicks. Proximity sensor was used to detect the presence of nearby objects without any physical contact. Camera was used also for capturing images. Lastly, LED diffuser for lighting purposes. Here is the flowchart of the main program. First, we must load the original image. This image is numerically represented as an array. It is in 3 dimensions. The first dimension refers to the width of the image. The second is for the height of the image. And lastly, the third dimension is for the channel of the image. After reducing the noise, we convert the color space of the image into grayscale. Through this, we reduce the color complexity of the image. From 3 channels, it will be reduced to 1 channel, which is an array that consists of the intensity values per pixel of the image. After converting into grayscale image, we then determine the features through edge detection. Through this, we can define the pattern to be matched with the dataset. For a female chick, the pattern is said to be alternating lengths, while for the male, the feathers have almost the same length. From the detected edge of the image, we are going to use it as a mask to separate edges to the original image. Through this, the edges will be more defined as compared to the edge detected using canny edge detection. After the binarization of the edges, the image will undergo feature extraction using SIF algorithm. This algorithm determines the local feature of the image that can be later used to match to our dataset. After the detection of the features using SIF algorithm, the dimensions will be reduced through principal component analysis. This analysis provides us the dimensions that are the most significant and help us extract the most useful information from the data inputted. After reducing the images, we can now classify the inputted data through the use of linear support vector machine. This algorithm basically creates a boundary between the classes. After plotting the inputted data, its distance from the boundary is then computed. If it's positive, then you can say that the inputted data is on the right side of the boundary, which falls under a specific class. From the image, it shows the visualization of the decision-making of the program. The inputted data is the red dot on the graph. The distance from the boundary is positive since it is on the right side of the boundary. With this, we are sure that the inputted data falls under the male class. Here is the experimental setup for the testing. For the table on the upper side, it shows the distribution of samples. We have 25 cockerels and 25 pullets for training. And for testing of broiler chicks, we have 50 cockerels and 50 pullets. And for testing of layer chicks, we have 53 cockerels and 47 pullets. And for the table on the lower side, it shows the time per batch or chicks. For the overall time per 100 chicks for expert is 150 seconds, for sexer is 200 seconds, and for our system is 250 seconds. For verifications of broiler chicks, confusion matrices were used to compare the data from the system and from the actual gender of the chicks. Then, the accuracy of the system is 89% for broiler chicks. And for the verification of layer chicks, confusion matrices were also used to compare the data from the system and from the actual gender of the chicks. Then, the accuracy of this system is 90% for layer chick. In this section, we will talk about the statistical analysis. For our null hypothesis, there is no significant difference between the actual and system's reading. Then, the hypothesis, there is a significant difference between the actual and the system's reading. Based on the value of P obtained from the calculated chi-square, the null hypothesis is accepted. Therefore, there is no significant difference between the actual and the system's reading for broiler chicks. While for the layer chicks, the null hypothesis, there is no significant difference between the actual and the system's reading. While the hypothesis, there is a significant difference between the actual and the system's reading. Based on the value of P obtained from the calculated chi-squared, the null hypothesis is accepted. Therefore, there is no significant difference between the actual and the system's reading for the layer chicks. Thus, the conclusion, the researchers were able to produce a device that classifies the gender of the broiler and layer chicks using image processing. Other conclusions are as follows. A hardware system was made. Next, according to the gathered data, the average accuracy for broiler chicks of the expert, newly trained sexer, and the system are 90%, 85%, and 89% respectively, while on layer chicks are 91%, 86%, and 90% respectively also. Then, according to the results of the statistical analysis, there is no significant difference between the actual gender of the chick and the system's reading. Lastly, let us enumerate the recommendations. First, the researcher suggests adding other domesticated chickens or similar breeds. Second, the placement of the sample on the base of the device would be easier if there is an outline of the coverage of the camera to avoid inclusion of the fingers of the user in the captured image. Third, cloud integration could also be added so that the database won't be limited to the size of the memory card on the RPI module. Fourth, other model of image classifier can be used like probabilistic neural network and adaptive neural network, which are more complicated than the support vector machines. Lastly, fifth, the researchers also suggest adding a touchscreen to easily access the database.